Good evening, my YouTube viewers. Crystal here. What I wanted to do is I wanted to give you a presentation of a program that I wrote about an analytics Vidhaya competition question called Felicity Kings of Machine Language. And this is an old competition question that I went through their closed competitions, and I picked it out. So it's a very interesting competition question because the way they did the data sets was quite unique, and I hadn't seen any data sets like that before. So since I'm not in a team and I don't have a mentor and I don't have anybody to help me, then I just had to guess. So when I did this, I just gave it my best shot, the best guesstimate I could come up with. So the first thing that we will do is we will read the problem statement. Dota 2 is a free-to-play multiplayer online battle arena called MOBA video game. Dota 2 is played in matches between two teams of 5 players, with each team occupying and defending their own separate base on the map. Each of the 10 players independently controls a powerful character known as a hero, which they choose at the start of the match, who all have unique abilities and differing styles of play. During a match, players collect experience points and items for their heroes to successfully battle with the opposing team's heroes who attempt to do the same to them. A team wins by being the first to destroy a large structure located in the opposing team's base, called the Ancient. You're given a data set of professional Dota players and their most frequent 10 heroes. The data also includes details about the heroes, kind of hero, nuker, initiator, and so on, their base, attack, strength, movement, speed. Here, both train and test data set are divided into two data sets, train 9 CSV and train 1 CSV, and test 9 CSV and test 1 CSV. Train 9 CSV and train 1 CSV contain the user performance for their most frequent 9 heroes and 10 hero respectively. Both train 9 CSV and train 1 CSV have below fields. Test 9 CSV contain the different set of user, different from training set performance for their frequent 9 heroes. Test 9 CSV has similar fields as train 9 CSV. Now the aim is to predict the performance, that's a key KDA ratio of the same set of users, test users, with the 10th hero, which is test 1 CSV. So that's very interesting problem statement. What I would say that if a person is really good at programming, then they probably would be able to assign each hero a number, and so each hero would be weighted, and depending upon the hero would also depend upon the weighting, and then you would create a new column with the weighting. That is something else that could be done, but since this is my first attempt, I only just now thought of it as I was giving you this presentation. So I might try to do that. I might try to give each hero a weighting, create a column to give each hero a weighting, and see if I can increase my score that way. So after we have imported our libraries, we imported pandas and NumPy, then what we do is we load our data sets. So we've loaded train 9, we've loaded train 1, we've loaded test 9, we've loaded test 1, we've loaded sample, we've loaded our heroes. So now we know what the heroes are, and we know like what their ID number, their primary attribute, their attack type, roles, base hero, health, all kinds of stuff about these heroes, that if you're going to really try to win this competition, it's probably best to know about all the heroes so you can give the heroes a weighting, which I might try to do that. So then we're going to merge the data sets. So I decided that we're going to concat the data sets. So train equals PD concat train 9, train 1, test 9. And we're going to make it all one data set of 29022. So what happened there was train 9 and test 9 and train 1 were added together. And I just guessed this. This is my best guesstimate because I don't have a mentor. I don't have anyone to help me. And then what we did was we checked our null values. And fortunately, in this instance, we didn't have any null values. And then what we do is we define our X and our Y values. So we created a variable called ID, and ID equals test1.id. Y equals train num wins and KDA ratio. X equals train drop ID num wins and KDA ratio. And X test equals test 1 drop ID axis. And then what we do is we're going to create our column transformer. And so what we did was we created a column transformer for numerical features, and all of the 3 columns that we were going to transform are numerical. So they were all going to go through an iterative imputer, but since there's not any null values, that's not going to happen. And then they're going to go through a scalar. There's no categorical values, and because there's no categorical values, I just made the section with categorical values a remark. So I didn't delete it, I just made a remark. So if I want to go back and do something that has a categorical value, then I've still got it there. And then we've got our preprocessor, which is a column transformer. And the only thing we used was the numerical transformer because that's all we have is a numerical transformer. We don't have any categorical transformers at this time. So now what we do is we split X for training and testing. And we do that using train test split with X and Y. Test size equals 10%, random state equals 1. And what we wanted to do is we wanted to check the shape of each column or each data set, really. And now what we did is, because CatBoost is not installed in Google Colab, we had to install CatBoost onto Google Colab. And then after that, what we do is we select our model, and we have to have a multi-output regressor, and we use CatBoost regressor. And if you go down, keep going down because it gave us 1,000. We'll just keep going down. I'm sorry it's taking so long. Okay, and then so we had a 78.5% accuracy on this cat boost. And then when we tested it on our validation set, we had a 47.86% accuracy. And then we predicted on our test set. And when we predicted on our test set, what we did was we just used the KDA ratio. We did not use the anything else, because whenever I created my predictions and my YPRED, we said numWins was the first column of prediction, and keep going down here, and KDA ratio was the second column of prediction. And so what we did is we didn't use numWins. We just used ID and KDA ratio. And then we created our data set, which created a file called submission.csv. And when I submitted that file called submission.csv, I had value of 709.97, which wasn't great. Put me at number 60 on the leaderboard, but they didn't have that many people on the leaderboard, but I was number 60. So it wasn't fantastic, but it did put me on the leaderboard. It did get me a score. So what I will do is I'll create an extra column and see if I can weight these heroes and see what happens when I weight the heroes, see if my accuracy improves. That would be a good thing to do. So that concludes it for this presentation. What I'm going to do is I'm going to leave a link to my GitHub account in the description box below. So if you want to go along with me when I'm going over the code, you can. And if you like my video, please like, subscribe, and share. If you like the work I do and you want to support it, I've got my email address to my PayPal account down below, because I don't have enough subscribers. So the only way I can earn any money on this account is to ask for donations. And thank you so much for watching this video. And I look forward to making new videos for you where I learn new things and discuss with you the new things that I've